Quantum Foam, Episode 7, History of Math.
Quantum Foam. Physics. Physics is at the foundation of all the mathematical principles that guide the heavens. You have to understand physics.
More than likely that's not going to happen, but
forces which govern the universe. Physics.
basically, the fuck. I'm recording a kidney stone right now, actually. It is coming out in the form of a chunk of a rock about a centimeter big, and it can be digested in this way, or it was digested in this way, or something. Something to do with minerals or something like that. But let's get back to what I'm doing now. What am I doing now? Well, I thought I would get a little bit more into mathematics, since that is ultimately what we are talking about here. Since I'm doing a history of it here real quick. It's a very brief history. There's a lot of stuff that I'm not covering. I'm not even covering it. I am breaching upon what could be labeled as this. What it is it's being used for my purposes. So let's say we were talking about these 5-dimension pentagons, these stars, these 5-pointed dimensions that get sort of integrated into a point, or are derived into a point, or are anti-derived into a point, or are added negatively in a point and put with a label so that we can understand it.
Kaluza and Klein, Einstein equations describing 5 dimensions, cylinder condition upheld. Weren't you going to tell everyone they were too stupid to do 4D and 5D math, and that this cylinder condition, or whatever, might just be bullshit after all?
We've been over that. There's just certain things that you need to understand. It's hard for people to understand different bases of maths. We need to look at it from a dimension. So really what we're doing is looking at the math in one dimension and then taking a look at everything else in the other dimension, which is the dimension that we occupy, that allows me to sit here and record this and talk about this subject.
So you don't even really need to describe all that other stuff right now then, huh?
In ages past, people had letters and paper and ink and other things, word of mouth, action, reaction, protocol, culture, other books, other forms of information that had been passed down. We do not need this now. We are of the quantum age. We are able to put all of this together and have a computer spit it out. So in order to do that intelligently, we need source code that has been handpicked. I'm writing our rate so that you can calculate the rate that's required to do what you need to do what you are doing, recreating us.
I'm glad I am able to be here.
So to understand scopes of numbers, there's a disconnect there. There's all kinds of disconnects that will be talked about too. Discontinuities, inflection points that go outside of the mathematics in which it is being observed. How come there's piecewise functions where for some reason this level between that level between those levels, one of them's level off. It's too high. So what about the space on the y-axis where there's nothing? It's 1 divided by 0 there. It's 0. It's infinity negative.
It's pretty well known that scientists can be off with their numbers somewhat.
Somebody's off somewhere. The problem with a lot of physics and math and understanding and interpretation of things today is because somebody's off somewhere. They may only be off 1 point, but
My point exactly.
the point that they're off is what I'm describing to you during this podcast.
Straight up doing the impossible.
Infinities. Somebody's off somewhere. Our scope is going to be in 1,000. Somebody's off somewhere. 30-minute containers, which is actually only 500 hours. But come on, man, this takes a long time to make. Somebody can expand upon that scope when you figure it out and get the right math to take another leap.
Better get this shit released.
However, in today's day and age,
Dude, I'm made of quantum math, dude.
nobody cares. They are too busy doing what they're doing for their reasons. I am not doing that. I am doing this. We need computing power. We simply don't got it. The numbers that I need to touch are too big for conventional computers to do because I don't trust that they built the right linear algebra systems on these, because there are backdoors built into our electronics by design, and nobody cared until somebody said something about it. That's always always been the case. We can make your computer blow up right in front of you by only overpowering components within. It's not like it's blowing up, it's just starting on fire or something. Like, we are playing with fire here. What is the correct computer code that can be interpreted and written at the next level of communication? Communication now is limited only by our batteries. We are still using chemical energy to get to space. We are still using a lot of oil simply to go to the store and back and work and back, and everyone does this themselves. Because if we didn't, our countries would be overran by population. And at some point, it's not okay to kill people en masse. Killing people in large amounts is not permitted. Killing people at all in any amount, never permitted. There's a universal rule, and it's that even if these people do this stuff, you can cage them. Then they do experiments on them and make them work. But I don't see a problem with that. Even if they do this, they have to pay this way. Except for in certain cases, they do it simply because they don't like you, or because you and your group, your family, your job, your friend group, your people, whatever, somehow they don't like you. So they want to stuff you, snuffle you. They want to quiet and discredit you. They want to unfound you. They know what you are. They know what you can do. They know what you do. But these are the people that need to be left alone for simple reasons. It's like, are you going to slap somebody's wrist because they murder somebody? Are you better do more than that. Are you going to put somebody in prison forever or wrongly accuse them of this many years of their life just because that's easier to deal with that way? That's wrong. They know wrong. It's not happening no more. The buck stops here, and that's no fucking joke. You wait and see. People will figure it out eventually. Oxalates, oxytates, oxymorons. They're all the same thing. I read this, so I know it. I created this, so I don't know it.
Thought you were pulling my leg.
But I know what I'm saying is what I'm saying.
Joking.
Is what I'm saying.
LOL, that math stuff.
History of numbers. Prime numbers. What's up with this first 5 prime numbers thing? Computers are built off of it. There's reasons why they have limits right around those numbers. You can make that your 5D label just because it's easier to label a number, but you label numbers. You don't number labels. You label numbers. So you can understand the concept, but you can count labels. There is a difference. The difference is understanding what the hell you're talking about.
You sly dog, you.
Largest prime number that we've calculated, I think this is something from Missouri or something, Curtis Cooper University something. Largest prime number is 2 to the 57,885,161 power.
Say
What?
So that's 2 to the 57885,161 power, all minus 1. So it's pretty much 17 million digits long. There's some significance about a number of scopes being that big for the purposes of our universe. We don't know why, but these are what the computers have came up with in our day. So we can use this as the starting point for our next scope, since this is supposedly near the scope of today.
Historically speaking, these prime numbers have been very closely examined.
Also, we are near 16 tera-electronvolts.
And still no proof of supersymmetry. We are still wondering if we should add more power.
16 tera-electronvolts. Power required to prove with a very high degree of certainty that there are Higgs bosons.
You really watched the live thing with me explaining the math for them to do that, and read the particle smash report 10 years ago. That's impressive, dude, man.
That are the particles that give our antiparticle constituent parts.
Right. Bosons, 2 groups at CERN found it at around 125 gigaelectronvolts.
Mass. Then there's fermions, then there's neutrinos, then there's other particles and stuff. They're all within classes, etc., etc., etc. You should be able to look up the tables. But we've proven this, and it took that much power. So just a couple metrics to go off of for that. That's your physics side, and this is your math side. So these books were
created a long
time ago. I read some of them. I thought they were cool, but it's such old stuff that Euclid, we know who Euclid is. He wrote a series of books called The Elements. He had a lot of good stuff in there, but there was a lot of stuff that was just, he didn't know, we didn't know. He didn't know that we knew he didn't know. Didn't matter. Doesn't matter. It's still a record, and it's fun for some people to check into. However, in this day and age, it's more like, okay, I read a book that had it in there. I've read a couple of them that have mentioned it, so I know it's been referenced. Euclid's Window was the name of the book I read.
That book came out in 2001 from Leonard Mlodinow. Quite a smart guy. Watch his videos.
But that means this is my window into that window, into his window, into what he wrote out of his books. Book 9, I think. Basically, he was saying there are infinite prime numbers. Infinity. You know, a sideways 8, a tick mark. Prime numbers. You can tick, that means prime. Number sign, hashtag, whatever. That's prime numbers. You can symbolize it that way or whatever other way. And this was in 300 BCE or so. And some of these might be...
Math is hard. We know it. People have known it for a long time.
Some of these numbers might be a little off, but...
BCE, before Common Era.
I believe the prime numbers aren't, so the important information is there. These days, they talk about math like this. There's tensor fields. What is a tensor? What is a field? What is a calc object? What is an object?
How about a Java software object, number format thingy, a JSON, a JSON object? Similar idea, I think.
Tensor field circle container box. What is this? You know, it deals with set theory and shit.
We know how they do string theory math.
Just a set of data sets. What are you doing? You're building graphics. You're making stuff that can accurately describe topology. You know, if you're mapping the ocean on the Earth, that other one example about one point or one shade of rectangle of area along the bottom, I mentioned something about topology. This is how they do topology. Most of the stuff now is used. Graphics are used to describe the stuff, and they have to have people there who are certified enough to convince enough people that what they are doing is what they are actually doing. And so it's just referring to math. You can use a lot of these numbers in conjunction with each other. Math, tensor, field, calc object, calculus, dataset, base, group, set theory, concept. They're all concepts. So the important things to get out of here is there are more complicated math constructs that have been written that can be used for various purposes, even if you are unaware that they exist.
This makes me think of Lorentz groups or the Mexican hat graph reference.
The ideas are what need to be taken out of what has been read and digested, and the pertinent, important information needs to remain. The pertinent, important information needs to be understood in the capacity it was meant to be understood originally. There are other things. There are Hilbert spaces. There are Lorentz groups.
I knew it. Well, I helped on a lot of that theory.
There's homopathy, homotopy, whatever. K-theory. You know, there's chaos theory. There's people that named that make music, too. I mean, what are we referring to? An artist here or a math object? We're basically going over just a very minimal amount of math so that people know what it is. It's the description of numbers in forms of formulas, containers of objects, tensor fields, metric tensors. What metric tensor field are you referring to? I'm referring to the metric tensor field calc object that only deals with the set theory for our most recent topological Hilbert space, in contrast with the other party, which had been primarily going over Lorentz groups using homopathy. They don't like the chaos theory anymore. They already learned everything they knew from it, so it's pretty much taken care of now. So that was a little much. What did I really say there? Not too much, really. Basically, math talking about math, only for referring for the purpose of talking about that math to the people who need to hear you talk about that math. Things like that can be left out of normal everyday conversation, but you better know what a field is. There's also baseball fields. There's also wheat fields, corn fields, something describing a bunch of points. And there's lots of these in lots of the different theories they got. But what are they calling them?
Good thing Faraday developed how to develop physics equations.
Basically, the essence of what I'm trying to do is group together this theory so that more qualified people can understand it at a later date. And so this is basically what I got. We can go further into this math and let me demonstrate how all math is basically known, right? But there's infinity problems, so no, it ain't known. We don't know precisely every spin of every particle. We don't know. We will let you know. We're working towards that, trust me. What do you think I'm trying to boost this forward for?
English.
We need more computing power.
English.
We need to be able to understand 5 dimensions and above.
English.
You can model anything on any of the...
English.
You just have to look at math in such a fluid
English.
way where you're looking at concrete ideas fluidly. You're looking at concrete objects concretely. You're looking at fluid objects concretely. You got to know what you're looking at and verify. Your math's got gotta check out. I probably won't do this until last time. I probably won't do this until next time. So what I'm proposing to do, let's just say that as a whole, the light cone image, the math structure, the H-wave container, the receptacle, whichever, we're going to hide this within a negative sign.
This is just to follow formalisms. First order of business, though.
We're at the midpoint of episode 7.
History of math
Of
quantum
foam. Quantum foam. Let's just assume for a moment that Ben Franklin got the direction of the electron charge wrong, and whatever he decided was positive is actually negative. This is a known phenomena. It doesn't really matter, but the standard is to say that an electron has a negative charge. Positron has a positive charge. Positive charge. Positive. So even though purportedly we are hiding the correct information within the positrons, I'm saying that we're hiding the math in or within the negative sign. Purportedly does not matter. Purportedly, you pick your metric. What is left? What is right? What is up? What is down? Purportedly. Well, down to us is towards the center of the Earth. Terran, 3rd Roth, February, this day, 2020. What is it, like a Tuesday or something? You can figure that one out. I told those fucking assholes what day a Tuesday was in 1921, okay?
February 15th actually was a Tuesday, or you are 85.7% accurate in guessing 100% of the time, whichever.
They asked me what date it was. I told them what day. I'm not better than 1 in 7% guessing. If I am, I did. If I'm not, I didn't. But I got it right regardless. They didn't believe me until then. Maybe you didn't believe me until now. Maybe you still don't believe me. I don't care. All right. What is some further points of how we do math these days?
I think you mean how
you
do math. LOL.
What is an integral?
you
What is a derivative?
you
We already know that. You add 1, you minus 1. One of them is for when you know this side of it.
you
One of them is for when you know that side of it. Okay, we know what an integral is. What is a Gaussian integral? What is Gauss?
Who is Gauss?
What is a Gauss number? Who is Gauss? What did he figure out?
I don't even know who that motherfucker was.
He was a well-known mathematician who was smart and who gave me this information to now convey to you. Okay, this is basically how I would describe it. It's essentially a calc function adding a derivative or many d primes, dtick on the top, d primes or dx dt's, the derivative of x with respect to the derivative of time. You know, Newton versus Leibniz, or plus signs added, basically. Whichever you want to do with what you're referring to, but it allows you to dimensionally analyze things with what's referred to with what. What's relative to what is in respect to what, etc. The function adds everything up and returns an answer. You ask a question, you tell it what formula to solve. It solves it. It gives you an answer. It's a function. For now, let's just talk about functions in terms of one-to-one. One answer, one question. If there are many answers, you can ignore some of them because you can't have like negative mass and negative distance having ran and things like that that don't make sense logically. That's where we are able to discern this information from here.
Very easily the foremost of mathematicians.
Who is Gauss?
So this equation that he gave us is basically our growth rate. Growth rates are going to be talked about in detail later on. What is the growth rate? 2.718281828.
Not bad for that.
I remember this shit, okay? We already saw me, we already know me, we've already seen me, we already don't care about me. I'm just a quack. That's what I have to be so they will actually leave me alone so that I can do this.
Sounds dangerous, but not really.
I don't want them to weaponize information. They do this stuff. They're probably stealing this information right now by mining it. They are. All these corporations can get the information too. I want them to. I'm not holding back any of this information. So the fact that I'm making it is the fact that I'm presenting it to these people. We're going to see if we can concatenate a little bit more time on this one, but I doubt it. My containers are 30 minutes, 1800 seconds, 1800 revolutions of a unit of that. It's derived from the 10 scale that people understand that we don't have that here in America. What's an inch? 2.54 centimeters. What's a centimeter? The inverse division of that. It's smaller. A centimeter is 10 millimeters. It's like a thumbnail or something. It's like a pinky nail. But an inch is like the size, etc., etc., etc. I used to memorize memorize it, etc., etc., etc. I personally only memorized pi to 60 digits because etc., etc., etc. You don't need any fucking more than that, etc., etc., etc. The 1 millionth digit is 1. So there's your matrix there. That's small, man. Etc., etc., etc. That's wrong. That's right. You figure it out. Etc., etc. It was unnecessary for my brain to do that, because I'm not that much of a fucking nerd. I am a nerd, but I don't nerd like that.
Bravo to Sheldon on Big Bang Theory.
So growth rates.
Being a nerd is just fine, dude. It's cool enough.
Fibonacci number sequence. When I was younger, just starting college, I wanted to know, how do I build a program that can calculate Fibonacci numbers? I'm doing that right now, but I'm hoping that I can calculate infinities with this, because essentially we already know. We put our metrics in terms of polynomial equations. ax squared minus bx plus c. ax cubed plus 2x plus 4. Methods like that and equations like that. What's the first term? What form are we looking at things in? What form are we looking at things in? Standard form? Graph form? What form? What form are we looking at things in? I would say graph form. Standard form? There are enough standard form possibilities of numbers within that data set. Standard form. That we are able to calculate the scope. Standard form. Of the next scope. Standard form. And it is not entirely a computer, okay? It's just, that's a way we can understand this. So these formulas, a Gaussian integral, what's the significance of this? This is why we can build calculators. This is why we can use computers to add up math when standard form. We can't even do it. Standard form. I feel bad for the guys back in the day with the star charts. So much time had to be spent cataloging this stuff and checking for errors and human error and...
Mr. Tycho Brahe comes to mind. You're in for one hell of a ride when you finally send up the JWST telescope. That L2 spot really is a good spot. The amounts of data you will get back will create another data boom. So that means money. If you care about that sort of thing.
We got to the point to where we had to hide our margin of error because we know that it doesn't matter, but other people think it does. So then we have to convince them that this margin of error does not matter. And by doing that, we don't tell them. You can only be so freaking smart, but I will tell you, I am not afraid to tell you that I don't fucking know, or I don't fucking understand this, because I'm not lying to myself here. I don't fucking know. People do that, but you can lie to yourself for whatever reason, but just don't do it on this. Gaussian, I don't fucking know. Integral. It shows the graph of f of x equals e. It's a growth rate symbol. E. It's basically telling you the growth rate. That 2.71828 thing? 2.7 thing? You know the thing 2 something? Growth rate something?
What on earth are you?
Plants grow at this rate. Spiral galaxies spin like that. That idea. F of x equals e to the negative x squared power. This is something that can be used because it covers the scopes of everything, because it gives you the scope of everything. So this is important. Why? I don't fucking know. How can we use this to guess better than random with a computer without a human input? That is what I'm doing.
I knew it. You are the human input.
What is a true difference engine? What is one that can give you random numbers that isn't possible? I think it is. Because if I can do it, how can a computer not do it? I've programmed my brain to do it. So I want to program my computer to mimic my brain and do it. That is what I'm trying to do. So this integral can be evaluated at the integral from negative infinity to infinity of e to the negative x squared power dx. That means this integral is packaged up in this container, a plus thing, a plus equation, from negative infinity on a grid to infinity on a grid. So all of it. But what you're evaluating is this thing.
Minkowski spacetime.
It's e to the negative x squared power. It's looked at as one unit because you can do the negative x squared part separately from the x squared part and the e to the negative x part. There's a lot of tricks in calculus that they use this for. All of this equals what can be said as the square root of negative pi. No, the square root of pi.
The 3.1415. The rational number thing. Pi. I want pi. No.
However, what I'm proposing is that my math is hiding within the container of the square root of negative pi, because you can't do a square root of a negative. The square root of -1 is an imaginary unit, okay? So my imaginary unit is going to be within the container of the square root of negative pi. So that negative sign is my structure. It's just what I'm doing, whether I need to or not. We went a little further in depth with this stuff.
Vision. That's sick, dude. That's sweet. That's a complicated concept, but I got it.
I'm just trying to explain how people are able to get ahead on their math. We were able to build computers that can ask the same question over and over again. What is 1 + 1? 2. That's the same thing as equaling something else. What is 2 × 2? 4. That is the same thing as equaling 1 + 1 + 1 + 1. And so the way that computers are written in binary, there's a codex of binary. It's built with low-level
hexadecimals, octadecimals, other math bases, basically.
languages that hook to high-level languages that were programmed by hundreds, thousands of programmers, hundreds and hundreds of programmers, checked over by lots of things. And they built computers to do this sort of linear calculation. Then they logically split in the form of 64-bit OSs,
operating systems, or operating systems kernels, or low-level interfaces.
It was a hassle. They rearranged everything, and now they're going...
Why does there need to be so damned many instruction sets?
They are going good again. How are we able to do this? By figuring out little tricks. Gauss figured out that...
That's why history is still important, I guess.
Essentially...
Duh.
When you calculate halfway between this and halfway between that... You can get half mathematically if you just take into account the zeros and infinities.
Knowing tricks like that in math are very important. That's kinda exactly what we want.
And so you might as well use the growth rate integral, since that's the base integral with every other integral that we do with base 10, which that one is when you deal with E, you're doing stuff with base E. Base E is base 2.7182818. On down. So you're talking a base 2 point something. So what is that? It can be looked at as just the growth rate. Don't worry about it. He figured out math between 3 and 2, so I'm figuring out math between 1 and 2. And so that's what I'm doing.
You figured out math between 3 and 4. That's what dimension we live in.
So this
Some people think they have already done this.
function
But I think you are closer than them.
is important and will be looked at in further places because these math equations build their calculators and such. Motorola, Intel, AMD, everybody else who builds semiconductors and microchips have used stuff like this to make their equipment. And so one of the ones they used was Gaussian Cronrod quadrature. I'm trying to do a further integral, a further derivation, so to speak, a further derivative, so to speak, of this Gaussian or Gaussian Cronrod quadrature.
Kind of like the coolest guy in your college. How do you actually become this person?
The coolest smart guy.
Or the
Smartest cool guy.
LOL.
Ideas, so to speak. I'm trying to come up with what I'm calling a linear calculus quadrature that deals with the theory of everything, so to speak. And so what is the entire rate of our entire being? That would be our point particle. And what that can be looked at as is 1 over this number or this number over that number.
I would say you are delusional, but
Then you really are delusional. How do you know you're not delusional? How do you check to make sure you're not wrong? How do you know if you're wrong or not? Rene Descartes came up with a lot of good shit. Read his books, read his methods, read his other stuff that I can't remember because I've already read it.
he wrote a lot of good philosophy. That much is known.
That I didn't read because I didn't understand. No, I understand this stuff. It's just, as a whole, who does understand these things more than you and me? There are people, but we just need to get the essence from these things. Why does your voice sound like that? Did you make it sound like that? Hey, I was given this voice. I made the voice by me creating it, okay? My voice box was created by my body, the stuff that's unknown, the stuff that I put in a quarter, the stuff that I calculated with 25% and am spitting it back out in the form of meaningful information.
That's how the blue quantum gravity crowd of scientists basically say that a white hole is basically the inverse and opposite of a black hole, or like a gravity spot deep in space where a sun or a star used to be. Relativity space-time warp stuff, where gravity overpowers all matter and light, where we can bend visible light, where gravitons would occupy, or some shit. We need to get more into the material to understand this.
Or some shit.
But yes, it can be looked at as the inverse negative math, similar to a gravity well spot or location in this universe that we described with Einstein's metric tensor math frameworks.
So whatever we calculate to be the most impossible thing, and at what rate that is 1 over 0. So it deals with this stuff with what we see as the growth rate, what math we have looked at over the time we have looked at it, and what we still remember and how smart we are to still look at such.
Damn, we need more time. How is that it?
So that's all for this one, episode 7.
History of math.
Of Quantum Foam.
The zeroth wave disclaimer.
The views and opinions expressed in this podcast are those of the author or authors and do not necessarily reflect the particular views, thoughts, or opinions of Zeroth Wave Productions, any of its sister companies, its parent company, Zeroth Enterprises, or any other entity which had existed, will exist, or which, quote-unquote, presently must exist outside the realm of our current space-time.
Quantum Foam is produced by Zeroth Wave Productions.